Hello, in this tutorial we are going to learn how to print the content type of the body of an HTTP post request using the ESP32, the Arduino core, and the ESP32 HTTP async web server libraries. As target port, I'm going to use an ESP32 FireBeetle board from DFRobot. So, basically this tutorial is a continuation of the previous one where we checked how we can process the body of an HTTP post request done to our HTTP web server. But what we did before was a very simple handling of that body. It was basically just printing the bytes of the content. Nonetheless, in a real application scenario, we probably want to do something more complex. For instance, one thing that we commonly do is expecting a specific content type that a client should use in order to encode the data to send the data to our server. And for example, if that content type is not the one we are expecting, we can return back to the client a message saying that we do not accept that type, that content type. So in this tutorial, what we are going to learn is how we can obtain the content type of the body before we start processing it. For this simple tutorial, we are not going to do any kind of error flow depending on the content type. We are just going to print it, followed by printing the actual content. But we are going to test with two different content types, so we can confirm that the ESP32 is indeed receiving it correctly and it is returning it correctly to us. Obviously, for a more complex application, we could then do a check on the content type received and return an error message in case it doesn't fit what we are expecting. So before we jump to that part of the code, we are going to recap here this first part of the code where we start by including obviously the libraries needed for everything to work. Then we need the Wi-Fi credentials of the Wi-Fi network so the ESP32 can connect to it. And then we need an object of class async web server that we have used a lot of times in the previous tutorials and that expose the methods needed to configure the server. Moving on to the setup, we simply open a serial connection and then we connect the ESP32 to the Wi-Fi network so it can be reached by the clients connected to that same Wi-Fi network. And after that, what we have is the configuration of the route, which is pretty much what we did in the previous tutorial. We used the on method on the server object, and using this method, we can configure our route and define a body handling function that will take care of processing the body of the request. So I'm going to use again the previously used route name /post, and since we are just expecting post requests, we specify this restriction in this second argument of the on method, saying that this route only accepts post requests. As third parameter, we need to specify the route handling function. In this case, since we are not going to need any type of logic here, because here we cannot access the body, although we can access the content type, but since we are going to parse the body, it makes more sense, or it's easier to have to check the content type there. Basically, as I've said in the previous tutorial, at the time of recording this video, we need to specify this function even if it's not used, if it has an empty body, because if we set this route handling function to null, then the framework will not execute the body handling function. I'm not sure if this is a bug or undocumented behavior, but this is how it works at this moment, so we need to pass this empty function. And as for the parameter, we can pass here null because this corresponds to a file upload handling function, and we are not going to be dealing with any files here. So in this case, and for this fourth one, we can actually pass null because it doesn't interfere with the rest of the flow of the framework, and it doesn't cause any problems in the execution of the body handling function. So basically, now we have our handling function. As we covered before, we need to respect the signature of the function. This function needs to follow a predefined signature type. And the parameters that matter to us, assuming that the payload is not too big and it will not be chunked, basically is the sync web server request object pointer, obviously the array with the bytes of the body of the request, and the length of that body. So moving on to the actual implementation, here is where we are going to look into the content type. And basically the content type, in order to obtain the content type, it's really easy. Basically you just need to call this content type method of our async web server request, which is why I was telling that we can access this content type also in the route handling function. Nonetheless, since, as I already said, we are going to have some logic to handle the body, it is a little bit easier to have this logic here to check the content type here. So basically we call this content type method, which receives no arguments and returns a string with the content type. Don't forget that since we don't have the async web server request object, but rather a pointer to it, don't forget that we need to use this operator here in order to call the method. So after we print the content type, which is very simple, as you can see, we are just going to do what we did in the previous tutorial and iterate through all the bytes of the data. So we have our data array here, we know the length, so we have a stopping condition to our loop. We are going to print the content to the serial port just for testing purposes. Here we are just adding a new line, so if you want to try with different requests, we have a more friendly output. And at the end, obviously we need to return back to the client an answer, so the client is not hanging waiting for the server to say if everything was alright or not. In this case, we are always assuming that everything was okay, so we are going to return here a true 100. But in a more realistic scenario, probably we would be checking if this content type is the content type that we are expecting, and if not, probably we would have here a condition returning an error message to the client. We won't even process forbidden or a not allowed content type, but this would be a more realistic scenario. But here I just want to illustrate how you can get this content type and obviously then build the logic you need for your particular use case on top of it. So after defining the body handling function, what's left to do is calling this begin method on our server object, and our loop function can be left empty because this is an asynchronous HTTP web server solution, which means that we don't need to pull any object periodically because the framework will handle calling all the callbacks for us when the requests arrive, and it's all handled for us under the hood, and we don't need to pull any object, which is why these libraries are so good, and they are very useful. So I've already uploaded this code with my credentials to my here that it already connected to the Wi-Fi network and already outputted the local IP assigned to the ESP32 on my network. And now for testing, I'm going to use Postman again, which is the application I've used in the previous tutorial about handling the body data of a post request, and I'm going to use it again. And as you can see here, I've already two requests previously defined. So I'm pointing to the /post route because it's the only route that we have in our server. I've selected here the post method, and as you can see here, I'm specifying the content here in the text editor. And I've selected here plain text. Okay, so this is a content type. Text plain is a content type defined by the HTTP spec. So I'm going to send the request, and as you can see here, I receive an OK message as expected because I'm not going to do any error check on the content type. And as you can see here, the content type that I've received on the server is indeed text/plain. And here is a message that I have defined to send to the server. So now I'm going to test with another content type. So in this case, I'm going again, it's a post request on the same /post route, again specified in free text, but this time I'm going to use the JSON application /JSON data format. This is a valid JSON, but it doesn't matter for this case because we are not going to process it, to parse it. But basically this is a valid JSON, but it doesn't matter. What matters here is the content type. I'm going to send it to the server. Again, I receive an OK message from the server. And as you can see here, the server is printing again the correct content type, which is application/JSON. And as we have programmed our callback function, I'm again printing the content received. So as you can see, it's really easy to access the content type of the request, which is useful so we know how we can process it, or if we can process it. So this is something very commonly done when we are developing a web server. So this should be very useful for the typical use case or for a realistic application scenario. Hope you have enjoyed. Thank you very much for watching.